let's take a look. So the first thing is the sort of three-step strategy for getting something out of your problem-solving habits. So whenever you're encountering some sort of word problem of something you have to compute in your life, understand what it's asking for, what all the parts of it are, solve the problem, go through the mechanics of actually putting the information together to arrive at an answer, and then be able to explain it. So just take some sort of brief period of time to reflect on what you did to make sure that it's sensible and that it fits what you expect of the type of answer. Okay, so each of these we can break down into other components. But it's this three-step problem-solving process that this section is about, and it should be helpful moving forward. Like I said, after this section, we're going to go to probably the most useful part of the course, chapter 4, which is about finances. It's about mortgages, savings account, investment plans, budgeting, these sorts of things that can actually make a practical difference in your wealth management. And then also,
It's great to meet you.
after that, we'll have a little bit of stuff just looking at sort of natural phenomena, because understanding the world around you and understanding people's arguments and involves understanding the basic science of the data. That stuff has to do with natural processes. Natural processes, you have to understand things like exponential functions. For Purdue, you would have to understand that in order to know what's being spoken about with natural processes. Understand how realistic something is. You know, there are these things. Let me give you an example, actually. So if you look at the U.S. national debt, something a lot of people are really afraid of. And I mean, it just is really taking off. It seems to be sort of exponential growth in what the debt is. And there's a reason for that. The debt actually literally is with interest. And so it is something that's literally exponentially growing. So we'll talk about that when we get into chapter 4. It's something that's literally exponentially growing. Now, how serious a problem that is, that's where the debate comes in, because there's also inflation, which actually has an exponential effect on things. The value goes down of the dollar exponentially with time, naturally with inflation. So that's a competing factor against the seriousness of the national debt. And some people say that the U.S. has such economic power that we can kind of be a bully in the world market in terms of the value of currency, so that we can force inflation to inflate away most of the problem of the national debt. The reality is there's some truth to that, and it's not true to some extent. Okay, so it's more complicated. But you have to understand the arithmetic and actually to even be able to be part of the discussion. All right, so let's break down each of these three steps. So the first one, trying to get my arm moving here. First one is understanding the problem. So what does this mean to understand the problem? Think about what is being asked of you. What is the problem asking you to do? Figure out what you need to do to make sense of the data given to you as a problem. Figure out ahead of time, before you come up with the answer, what should the answer look like? Maybe I'll try to give some examples of these off the cuff here before we get into other examples. Try to map out how it is you go from the data that you're given, you're going to set up the problems to the conclusion that you want. What are the steps that you would do to put that information together? And then keep thinking about your understanding of the problem as you're going through the actual step of solving it, and then afterwards when you're sort of checking yourself. And being able to explain the concept of the problem, how it works, to yourself or to other people. Okay, and so let me give you an example of some of this stuff. If I'm going to Pensacola to visit my sister-in-law, and Pensacola is about 600 miles away from here. In fact, from my house to her house is almost exactly 600 miles. And let's say I'm with my family, If I'm driving alone, it's not gonna take me that long to get there. So if I'm with my family, it's gonna take, let's say, 10 hours for me to get there. And then I could ask, what's my average speed? For that time, what's my average speed? In fact, that's not even it's not a very well defined question. A better question would be what's my average velocity? That's a different issue. But let's just keep it simple. Average speed. What would you say to that? I'm giving you the data. I'm doing 600 miles south, pretty much due south. It takes me 10 hours to get there. What's my average speed? Yeah. 60 miles per hour. So you have a lot of expectations baked into you from that problem. So you see, what does the problem ask you to do? Well, it's asking you to come up with the average speed. And then you think, well, how would average speed relate to the data that I'm given? Right? How would it relate to the data I'm given? I'm given the distance, and I'm given the amount of time. Right? I'm given those quantities. So you have to think, what's the relationship between distance, the rate of speed, and time? And so you can think about, how you put those data together to get the outcome. What should the solution look like? There's another thing. What should the solution look like if I'm asking the speed? It should look like something like miles per hour. It shouldn't be miles. It shouldn't be hours for the answer, right? It should be miles per hour. So that's what you expect. And once you know what to expect, then you know what you need to do to map out the path, especially if you think of the units. That's going to be something we focus on later in this section. But if you think about the units, it tells you what to do. I gave you two quantities. One of them was in units of miles, another one was in units of hours. And I'm asking for something where you know the units of it should be miles per hour, miles divided by hours. So it tells you what to do, divide. Take the number of miles, divide by the number of hours. Does that make sense? So the units actually tell you exactly what to do. And since we use this all the time, driving, doing this stuff, we're used to these sort of calculations. So that sort of word problem is not mysterious. I imagine to most of you at all, right? It's not that hard of a problem. Okay, so most of the things, if you break it down on that level, and that sort of way of sort of viscerally understanding it, because you had this experience of driving that long time, at an average rate of speed, then you'll be able to get through this. All right. Solve the problem. So you go about doing what you need to solve the problem. Get your data. If you need any other information, for example, maybe you need to look up what the volume of a cone is. Maybe that happens to be relevant information to your question. Your question is, I have cones of this size for ice cream. How much ice cream do I need in order to fill 16 cones? Okay, well then you need to know the volume of the cone. You need to know that volume, so you're going to have to look it up. You get the information that you need. If you have a lot of setup problems, which does happen, figure out how to organize your information. This problem with going to Pensacola, you may want to have a chart. You may want to write an equation. Distance equals rate times time. You may want to do something like that and make a table. Here's what I know, distance and time. Here's what's missing, rate. Now I have an equation. My number, 600, equals R, my rate of speed, times 10 hours. And then it tells you how to solve. Okay, you're used to solving linear equations. So figure out how to organize your rate. Okay, it's true, yes, you should double check and practice. You're probably not going to, because you probably know what the steps are for going through and solving the problem. But yeah, double check. Make sure that you aren't getting any crazy answers. Especially if you have a multi-step problem, you don't want to have the first step be a ludicrous, nonsensical answer, and then go on from it. So if I ask something really complicated, and the first step of it was figuring out my average speed on my trip to Pensacola, and you do a calculation, you come up with an answer, -6. Okay, that's absurd, right? That's absurd, so you know something's wrong. So keep track of reality and don't waste your time. This constantly reevaluate the plan as you work, and there's some validity to this. It may be that what you're doing is too hard enough, that there's something easier you can do. So, I decided for this slide I didn't want to separate it. Okay, and I explain the result. Now this is one that you don't have to put a lot of work into this. The top one is the main one. Be sure that the result actually makes sense. Yes, it's a very important thing. Yes, recheck your calculations. But really, it's just reality check. Does the answer actually make sense in the context? Again, if I give you the question of me going to Pensacola and you get an answer of 600 miles per hour, something would have to be wrong. And it would either be your setup, how you're reasoning through it, or a calculation. And you need to go and identify where it is you messed up so that you can fix that. But if you're able to explain the result to yourself or to somebody else, then you know. You know, there are a couple of sayings that have to do with teaching. One of them is, if a person can't do anything, they teach. I think that's one of them. You're not good at anything, then you teach. I guess that's one of them. But another one is, if you really want to understand something, teach it to somebody. If you want to convince yourself that you actually know what you're talking about, if you get to the point where you're able to explain this to somebody so that they understand it, then yeah, you're probably at the point that you understand it. And if you can't explain it well to somebody, it could mean it's a possibility that you don't understand it as well as you thought. Another possibility is actually you just not effectively communicating, so you need to work on that. That's why I always say, math courses, this stuff is very important. You really need to, like, a big priority out of your university experience should be the ability to communicate your thoughts to other people. Like, doing it effectively. That is extremely important. Everything that we do, there's some social aspect to it. You need to be able to do that. That's extremely important. So this stuff is important. That's more important. You have to be able to communicate what it is you're thinking. Well, actually, it's jumping right into unit analysis before we do that. Yeah, okay. Let's do this thing first. All right. So what we talked about when we're saying unit analysis? I almost said urology. So units are things like meters, seconds, miles per hour, apples, ducks, hertz, curies. You know that for radiation curies. Rad, another one for radiation. What else? Watts, joules, newtons. They are quantities that tell you what type of amount you're talking about. So if you're talking about apples, your units will be apples, 6 apples. So if you keep track of the units with the quantities that you're discussing, it's actually quite helpful. People usually are lazy and don't do that, but it does help make things clear if you know what the type of object is that you're talking about. Now, sometimes quantities literally just don't have a unit associated with them. But that does happen. It could be the case that you're talking about something that's specifically a ratio of, say, apples in your bucket to apples in my bucket. So we take 25 apples divided by 5 apples, and you get an answer of 5. 5 is that ratio. And it doesn't have a unit associated with it. It's just a number. That happens. But usually in most real world problems where you're talking about something in reality, usually your numbers do have something associated with them, units. Maybe it's apples per second. I'm throwing them out. 6 apples per second. Okay, that's a unit. Apples per second for me to be able to communicate with. The units tell you what the number is needed. And so unit analysis is when you're given some problem, like the Pensacola problem, and you're given miles and you're given hours, you're asked for speed, you think of the units for speed, and it tells you what to do with the quantities, because you know the units associated with it. 600 miles divided by 10 hours, 60 miles per hour. Okay, so that's unit analysis. The units is the idea that the units are telling you what to do to answer the question. So you are buying 30 acres of farmland at $12,000 per acre. What is the total cost? Okay, So let me ask you some questions about this. What units do you see in here? Can you tell me some of the keywords in here that are units that tell you what is going on? Yes.
Acres.
Acres is one. One unit is acres. We have 30 acres of farmland. Yes, another one. Dollars per acre. Dollars per acre. That's another unit in farm. We have 12,000. That's a number. But what that number is representing is dollars per acre. That's the unit. Dollars divided by acres. Okay, so how do you think you can combine? What operation can you do to combine the units of acres and dollars divided by acres, dollars per acre, in order to get the answer for how much? What would you do? Yes? You would multiply. If you take acres times dollars per acre, you're going to get dollars. And if you look at the question, it's asking what's the total cost. You know the unit for that should be dollars. Right? It shouldn't be acres. It costs me so many acres. That wouldn't make sense. It's costing me dollars. So just from the units, you can get this meaning. Now, there is something hidden in this discussion. We have to know what that word per means. The word per. And anybody tell me, what does the word per mean? I'll give you some description. Yes?
It's like each. Like.
Yeah, it's like
Yeah.
each. For each, it's this.
Mhm.
And it implies a math operation. You know what that is?
Division.
Like miles per hour. How do we write it? We write it with the division bar.
Yeah.
So that's division, right? So it's dollars per acre. It's dollars. You take the total price, divide it by the total number of acres. That gives you the unit of dollars per acre, right? So that per is telling you that the units for that number 12,000 is dollars divided by acres. Okay? And that's how we knew that we have something where we need to multiply by acres to cancel out that acres to the bottom and get just dollars left. Okay, so we have our entire strategy built up by understanding that keyword per and understanding what the units are. Okay, so yeah, looking at the steps of problem solving. So understanding questions, asking about total costs. And one of the units is dollars. Well, I don't think that's actually true. One of the units is dollars per acre. But we do expect from that the answer is going to be in dollars, not in yen or rubles. Right? We expect the answer to be in dollars. So we're looking for a way of getting dollars. Okay? If it's the same keyword of, that's actually true. The word of means multiply usually. It's usually a good way of translating it. It's saying 30 acres of farmland. So it's 30 acres, and each one is $12,000. Right? I would say the more important word here is per, to know that that means division, dollars divided by acres. But it's just perspective. So we take the 30 acres times the $12,000 per acre. And you can see right here, if I were to take, think of this as a fraction, 30 acres divided by 1. So think of a fraction bar with 1 underneath it. You can always do that. You're always justified in dividing by 1. Then I have a fraction times a fraction, and I can cancel out common factors at the top and bottom. So I have acres up here, canceling out the acres down here. Okay, and if you do that, the acres gone, but you still have dollars as your unit. And that's exactly what you want. You want to have dollars as your unit. So then you just multiply 30 times 12,000, that's 360,000, and you still got dollars. Okay, so that's the solving step. Oh, look, you process it out right there. Process it out there because, actually, maybe this is a good thing to review. Why are we justified in crossing these out? That's a very good question. That's a very good question. Maybe, I don't know if I can actually manage this with my right hand here or not. Let me see if I can. I want to try something with my hand. See if I can write it. Because why not? With me and brush. Make it big. Okay, that'll be fine. If I take something like this, 2, that's a beautiful 2 plus 3, and I divide it by 3. Why is this wrong?
you're supposed to be dividing by 3, so like they're two separate terms.
It's two separate terms. Yes, that's right. It's two separate terms. Think of it this way. Think of it if I start with 2 and I'm building up that quantity on the left side of this line. So I start with a 2 in the numerator and I'm building up. What do? I add 3 to it. And then I divide the answer by 3. If it were the case that I could cancel out that 3, this would suggest that to undo adding by 3, I could divide by 3. That dividing undoes addition. And that's not correct, right? That's absurd. Division doesn't undo addition. What undoes addition? Subtraction. Subtraction is the opposite. So what is division the opposite of? It's the opposite
Multiplication.
of
Multiplication.
multiplication. So when you're canceling with fraction bars, you're canceling factors of something. It has to be something multiplied by 3 and then divided by 3. Then those cancel. So instead of the plus here, let's see. Instead of the plus here, if I take my tiny erase tool and I erase this thing, if instead of plus and then a times, oh, the pencil tool, that's better. Here, this is a times, just a dot for times. Then this would be correct. This would now be correct. If I take 2 times 3 divided by 3, then it can't make sense. Why? Because division undoes multiplication. That's why we just apply canceling whenever we have multiplication. Right? So that's something to keep in mind. And then it's being divided by figures. So the division undoes that multiplication. That's why we cancel. Does that make sense? That's the reason we cancel. All right, but anyway, there's that step. Now we want to do the explain. So this is the, did I understand this right? Is this a sensible answer? You know, is this what we expected as an outcome? So you figure out that the land costs $360,000 and it came out with the right units. It came out with the right units. If land costs $12,000 per acre, you expect 30 to cost a lot more than 12,000, right? So if I had an answer of 3,600 instead, you would know something's wrong. That would be a nonsensical answer. It shouldn't cost less for 30 acres than it does for 1, right? So it's just reality check stuff. If you make an error, you do your thinking, you just forgot a 0, then your 3,600 or 36,000, it wouldn't make sense. It wouldn't quite make sense. So it should be something that is obvious when you sit and reflect on the answer. Okay, so we actually already used unit analysis. Now that's when we get to explicit suggestions for unit analysis. Yeah, so this is a good one. You cannot add or subtract numbers with different units. But there are ways of getting different units from expressions. Combining different units. Just like the miles and the hours, division gives us miles per hour. And you could invert that. It's perfectly reasonable to talk about hours per mile. There's nothing wrong with that. It makes perfect sense. It's just not our standard way of understanding speed. Okay, but it's perfectly reasonable. Perfectly reasonable to think about that. But you can do it through multiplication, division, or reason. If I take 5 apples plus 3 oranges, I don't have 8 apples or 8 oranges or 8 apple oranges or something like that. I guess, I mean, according to this though, if I had 5 apples and 3 oranges, I could multiply them and get 15 apple oranges. But I don't know what that unit means. I don't know what that unit means. There are times when you do that though. The unit for work, I can explain to you what work is. In physics, work is force applied over distance. And think about if you're pushing something really heavy. If I push something really heavy for a meter, maybe it's not very tiring. I feel like I've done a lot of work. But if I take that thing that's heavy and I push it for 100 meters, then I'm probably going to feel tired. Right? I felt like I've done a lot of work. Our unit for work is force times distance. The distance that you apply that force. And so the units for it, we come up with a convenient name for it to make it simple. We call it joules, named after a person. But you could also call it Newton meters. Newtons times meters. Newton is the unit of force. makes sense, students times meters, it actually does make sense. I don't know what apple oranges would do, I don't know what kind of that would be to do that. Yeah, okay, this is fair, this is fair. It's easier to do division with multiplication by the reciprocal. When you're doing unit analysis, the natural way that units appear is as a quotient, miles per hour. It naturally appears as a quotient. So even if you have decimal numbers, it's just convenient to write it as a fraction. And if you divide by it, write the reciprocal. It's just convenient to do that because it makes the units